Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve a thermal analysis of a pressure vessel. So it has a material of steel with an Young's modulus 210 gigapascal and Poisson ratio is 0.3. Here what we are going to do, we are going to do only a thermal analysis. So the required property to do thermal analysis is thermal conductivity, which is 45 watt per meter Kelvin. Now we'll see the boundary condition. So inside of the vessel the temperature is 550 Kelvin and the outside with an external convection with an external temperature of 293 Kelvin and heat transfer coefficient is 25 watt per meter square into Kelvin. Now we'll solve this pressure vessel thermal analysis problem using salome. Now I open salome. First we'll go to geometry model. This pressure vessel I have already designed using a designing software and saved as a step file. Now I will directly import that step file into the salome. For that, just go to file, import step, so here, so this is my file, just open it. So I have modeled in mm, so I just want to keep it in the meter, so for that just give yes. So after importing any file into the salome, first check the dimension of the model. Just go to inspection, dimension. We can check by any dimension, by minimum distance, angle or manage dimensions. Now I am going to use with the bounding box. From that we can check with the maximum distance. It will build a rectangular box over it. So now we can check along x direction, it is minus 0.5 to plus 0.5, that means 1 meter vessel. Yes. Now the dimension is correct. Now we'll create a groups to apply the boundary conditions. For this thermal analysis problem, we have two boundary conditions. One is inside the vessel of 550 Kelvin temperature and outside there is a convection. So now first create groups, surface group. First we have to create inside surface. For that we just want to hide the outside surface. So just select, press the shift and select the surface, all the surfaces. These surfaces are outside surface, this is not required. Here we can use hide selected. Now outside surfaces are hidden. Similarly here also just select it. Here also just select, just add it. Now we have added outside surfaces. Now whatever the surface which is showing is inside surface of the vessel. Now what we can do, we can just simply select it. Yes, now I have selected all the inside surfaces. Just click add. Here we can name inside surface. Just apply. Now I have selected inside surfaces. Now again you just go here and change it to here. So all the subshape. Now it will show all the subshape. Now what we want to do, we want to select outside surfaces. For that just select all the surfaces, then you just remove only the inside surface. Further just select the inside surface, just remove it. This is, you name it outside convection. Just apply and close. Now we can check this groups also. See here, the insert surface is not available in here. So now whatever the surface we have selected is correct. So these are inside surface, these are outside surface. Now we can go for mesh model to create the mesh. Before that, I'm just saving this file, save as. So here I just saving here. Now I have saved it. Now we'll move into mesh model to create the mesh. Just go to mesh, create mesh. This is a not the hexagonal shape. So here we can generate only tetra element. So to generate a hexa element, we have to partition the object into smaller hexa geometry. That will take some time. For the study purpose, I'm going to use tetra element. There are two hypotheses are there. Here I'm going to use NetGen 3D parameter. Here we can specify coarse, fine, moderate options like ANSYS. Here I'm going to use fine. Just say OK and apply and close. Now just simply right click this mesh one, compute it. Now here you can see the mesh is generated without any error, and also the mesh wherever the smaller surfaces are there it is generated a finer element, where a bigger surface is there it has generated coarse element, and the pressure vessel is also a very less thickness, so it will generate only one element along the thickness. To make it more elements, we just want to increase the number of elements. For that it will increase the number of node also. Now we have generated linear element with 48,207 nodes and 1,93,970 tetra elements. Close. Now we have generated the tetra elements. Now what we can do? Now we'll check the groups also. The groups also taken into the mesh. Now we will move into the aster study to create the setup to solve the thermal analysis. Just go to aster study. Stable, just say OK. Here we can generate the setup by using one by one also. Here we have assistant also. Directly we can use the assistant to solve this problem. Just go to next, again next, 3D problem. Conductivity of this is 45 watt per meter Kelvin. Impose the temperature on the groups. Inside surface it has maintained the temperature of 550 Kelvin. Just go to next again. There is no heat flux, surface heat flux. Then there is no volumetric heat source. Just save this file. Partial boundary condition only we have applied. So now it has generated the setup, not complete setup. Now we will check one by one. So we are reading the mesh. We are defining the model. It's a thermal model. We are defining the material. It is a steel with a thermal conductivity of 45 watt per meter Kelvin. We have assigned the material to the model. Then we have applied only one boundary condition, that is inside temperature. Then just double click here. Then we need to apply convection boundary condition. For that we just select this exchange, edit. Here we have to choose the group of element as outside convection. Say OK. Then heat transfer coefficient and external temperature. External temperature is, here you can see 293 Kelvin, and heat transfer is 25 watt per meter Kelvin. Just save OK, just apply and save OK. Now we have applied convection boundary condition also. Now just go to the analysis. Now we need not to modify, the same only we have included. Just save it. Now what it will do, the linear solver only calculate the temperature. If you want to calculate heat flux also, just go to post processing, call champ, use the same name. Here thermic, here we have to choose flux LNO as well as flux nodal. Then just apply and OK. Now we have calculated this using call champ. Then we have to save the data. Just simply modify, instead of temp thermal linear, we have to choose temp call champ. Here tau champ, make it yes. Just save OK. Then you just apply and OK. Now it is done. What we can do now, we'll solve the case. Just go here, run it, make it this into 5 seconds. Here I'm just increasing it to 4 GB. Then you just run it. This is simple a thermal analysis of pressure vessel. The same problem we can add, we can create the setup by one also, but the assistant, it will generate setup very quickly. Now it is solved without any error. Here also we can see it, diagnostic job is okay, there is no error came in this command file. Now we can go for paraview to see the post processing. Just go to paraview. Only two variable we can check, one is temperature variable, another one is heat flux variable. So first to open the file. So here this is my file, just open it, just apply. Now we have created a little coarse mesh, here you can see. So by going fine mesh, here like this we can see the smooth surface. So here we have created a little coarse mesh. So now just go to temperature. So this is the temperature pattern. So this is the temperature pattern. So the maximum temperature is 550 and it reduces to the minimum temperature of 520. So the vessel is in the dangerous condition, like that we can see 520 Kelvin it will see. So now we can see this value we can change into rainbow blue to red, and here we can change this into 12. So this is the way we can see the results. So this is the temperature profile for pressure vessel. We can cut the section and we can see the temperature also. So there are two options, one is slice, another one is clip. Use the clip, and here we can change the normal surface. So Y normal, Z normal, just apply. So like that we can clip the pressure vessel, we can see the temperature inside the vessel also. So this is the way temperature profile, temperature conduction is happening. Now we have completed solving a thermal analysis of pressure vessel using salome meca. Now we'll see the next case in next tutorial. Please subscribe my channel for more videos and click the bell button for notification. Thank you.